All right, guys. So we've been talking about our heat exchange, our with our Cheeto lab, right? And so now what we're going to start talking about is endothermic versus exothermic reactions. Okay, so to start here, let's kind of come with something familiar, right? We've talked about phase changes, where we can go from solid to liquid, we can go from liquid to gas, right? And we know that going in between these phases, right, we are changing the energy, okay? So if we're going from a solid directly up to a gas, right, this would be a sublimation reaction, right? A sublimation phase change where we're going directly from a solid to gas. And to do that, right, we have to increase the energy of our molecules, okay? If we're going from a solid to a liquid, right, we know that this would be melting. And then from our liquid to a gas, that would be boiling, right? Each of these phase changes, right, we are increasing the energy of the system. So if we are increasing the energy of our system, right, it is absorbing that energy, right? So that is an endothermic process, right? The system absorbs or takes in some of that heat energy, okay? But we could also release that energy, right? If we take a gas and we condense it to a liquid, condense, or if we take a liquid and freeze it to a solid, right, it is going to be releasing that energy, and so it's going to be an exothermic process, okay? The last piece here, if we have a gas and we go directly to a solid, this would be called deposition, okay? So each of these words, right, we're kind of probably mostly familiar with going from a solid to a liquid, liquid to a gas, but we can actually also go directly from a solid to a gas. This would be sublimation, and a gas directly to a solid, okay? So don't worry too much about those vocab words, but we're probably somewhat familiar with them, okay? So again, right, any of our changes, whether it's a physical change or a chemical change, can be classified as either endothermic or exothermic, okay? So the way that we can kind of write this, right, if we remember, we have H2O, we can designate it as a solid, and it's going to go to H2O liquid, right? We have talked about this physical change where our solid molecules, right, we give them enough energy to break free of some of those intermolecular forces. We have to give them that energy. So our enthalpy change, which is delta H here, is equal to 6,010 kilojoules per mole, okay? So we've talked about how we have to give the system energy, right? So this is a positive number because we have to give it that energy. So it is an endothermic reaction, okay? What about an exothermic reaction? Well, we could take any of our exothermic reactions from up above where we went maybe liquid to solid or we went gas to solid, something like that. But we could also start to think about storage, energy storage. So one of the exciting ideas for energy storage of the future would be to have H2O, maybe it's a gas, maybe it's a liquid, whatever it is, but we can split those particles up and we can form H2 gas and O2 gas. So when we do this, right, we have to put energy into the system to split those particles apart. So if we're putting energy into the system, our enthalpy value should be endothermic. But then when we go backwards, say we have H2, right? We've got hydrogen that we've stored. We could mix it with oxygen and react it. And when we react it in our engine maybe, right, maybe all we do is we form H2O gas, right? We just make water. Now, this reaction is going to be exothermic. and we can use that exothermic energy, right, that energy that gets released by the system, to actually to actually fuel our cars, right? So when we split it up, we have to put energy into the system. This would be 483.6 kilojoules. Okay, we put energy into the system, and we store that energy, and then when we want to use that energy, right, we can use that energy and release it. So now it's going to be, our enthalpy is going to be negative 483.6 kilojoules per mole, right? We released the energy here, okay? So this is kind of how some battery technologies work, is we do a certain reaction, and we store that energy, and then we take that energy and we flip that reaction over to actually then turn our motors, okay? So this is an endothermic reaction where we put energy into the system, we store it, and then we have an exothermic reaction where that energy can get released, okay? All right.